This is tutorial chapter 9, which is on nuclear and particle physics. Okay, so question 1. Determine the mass defect in atomic mass unit, binding energy and binding energy per nucleon. So binding energy dia mau dalam mega electron volt dengan joule, and then binding energy per nucleon in mega electron volt per nucleon for the following elements. Okay, so we have gold, aluminium and lead, and then according to the element given, arrange the elements based on their stability in ascending order. Okay. Okay, so this is quite a lot to do for one question. So first we have the gold, which is the aurum. I'm just gonna make this a little bit smaller because I'm using the brush pen. Just don't really like it when it's really big. Okay, so okay, that's too small. I'm just gonna do 0.5. Sorry for the delay in this question. Right, so we have gold, so that is aurum, and this is 197, this is 79. So first we are gonna do the mass defect. So for the mass defect, right, so do they give us anything for the following elements? They just literally just give us the mass of okay, right. So for the mass defect, that is delta M, and we know that delta M is equal to Z MP plus NMN minus mass of nucleus. So since the question just give us the atomic mass, meaning we have to find the nucleus, mass of nucleus lah. So the mass of nucleus, as we all know, it is basically the atomic mass minus the value of proton, the number of proton punya mass. Since this is an atom, the mass of electron will be equal to the the mass of the number of electrons will be equal to the number of protons. Okay, so this is how we calculate the mass of nucleus. Okay, all right, so Z is basically, this is Z, this is N. So A is, not N, this is A, and N is equal to A minus Z, which is equal to 118. Right, so that is that. And then let me just write it down here. So Z is 79. Mass of proton is given as 1.007277 plus dengan the nucleon number, which is 118. Neutron number, which is given as, that is mass of neutron, which is 1.008665, and then minus the mass of nucleus, so that is basically atomic mass of aurum 966,543 minus with 79. This is, what is the mass of electron? 0.000549. Okay, let me just drag it here. Kenapa begitu tu? Okay, let me just put that here. Okay, so hope you are not confused due to the many numbers here. Okay, so delta M, kalau kamu calculate, you will get the mass defect to be equal to 1.674181 U. Okay, so that is the mass defect. Lepas tu dia minta apa? Dia minta binding energy. So we know that binding energy is, dia minta dalam mega electron volt dengan dalam joule. So first we are gonna do dalam mega electron volt. So for the mega electron volt, it is just 931.5 mega electron volt. So this is 1.674181 darab 931.5. So you will get 1559 mega electron volt. Lepas tu dalam joule pula, we are gonna use delta M C square. But first, our delta M ni kita perlu convert pergi kilogram. So how do we do that? Is we are gonna times it with 1.77. Oh, sorry. 1.67. Gosh, I don't remember. Let me just check. Where is the... Okay, here. So 1.66 times 10 to the power of negative 27 kilogram. So that is 1.66 times 10 negative 27 kilogram. Barulah kita darab dengan the speed of light, which is 3 times 10 to the power of 8. Okay. So this is 1.674181. 1.66 times 10 negative 27. This is 3 times 10 to the power of 8. So hopefully I didn't do anything wrong here. So if I don't, you should get the correct value lah. But let me just calculate it really quickly. This is 3 times 8. So you should get a... Okay, no. We did not get the correct answer. I get 8.674181. What is the speed of light? It is 3 times 10 to the power. Oh, I forgot the square. Patut lah. Okay, so don't forget to square it and you will get, yes, the correct answer. 2.5 times 10 to the power of negative 10 joule. Okay, so instead of, if you want to do it this way, it's really not a problem. But you can also actually directly do from here. You can actually do it this way. So from mega electron volt, kita boleh terus convert pergi joule. How do we do that? Is we are gonna use okay, so we know that 1 mega electron volt is equal to 1.6 times 10 to the power of negative 13 joule. So instead of buat darab dengan kilogram na to kamu rasa susah, kamu juga boleh darab dengan 1.6 times 10 to the power of negative 13 joule. Okay, kalau kamu buat macam tu, you should be getting the same answer lah. So for this one, kita darab dengan 1.6 times 10 negative 13. Kita boleh dapat dalam joule sudah. So let me just calculate it. You'll get... Yes, so you should get... Oh, ada difference sikit je lah. Kamu dapat 2.49. Tapi sama jugalah 10 times negative 10 joule. Okay, so kamu boleh juga buat macam ni instead of doing like this. Okay, so lepas tu kita perlu cari untuk aluminium. Right, so I have to do it in another paper. So firstly, I'm just gonna quickly write the atomic mass of aluminium. First, aluminium is given as 27. This is 13. And then the atomic mass is given as aluminium is given as 26.981538 U. Okay, so sama juga kita perlu cari mass defect. So delta M is equal to ZMP plus NMN minus mass of nucleus. So again, since the question give us the atomic mass of the of aluminium, we have to find the mass of nucleus lah. Okay, so delta M is equal to Z is this one is A. So the neutron number is A minus Z, which is equal to 14. So this is 13. This is 1.007277 plus dengan N, which is 14. This is 1.008665 minus dengan mass of nucleus, which is 26.981538. We minus dengan the number of electrons. That is Z. Z is given as 13. This is... Wait, let me just rewrite that. 13. This is mass of electron, which is 0.000549. Okay, so delta M, kamu akan dapat 0.241510 U. Okay, so that is the mass defect. Lepas tu kita perlu cari binding energy. So binding energy, kalau dalam mega electron volt, I would just do it as like this. Okay, so yang ini 241510 931.5. So you will get 225 mega electron volt. So and then in joule, you can do delta M in mega electron volt. Salah. Kamu darab dengan 1.6 times 10 negative 13 joule. So you will get 3.6 times 10 negative 11 joule. Okay, so that is the binding energy. And then I think I forgot to do the binding energy per nucleon for this one. Yeah, so basically the binding energy per nucleon is just mega electron volt kan diminta, divide by A, which is 197. So you'll get 7.916 mega electron volt. Okay, so do the same thing for this one. Since dia minta dalam mega electron volt, we are using the mega electron volt punya value lah. 225 divide by A, which is 27. This is 8.332 mega electron volt per nucleon. I forgot to write per nucleon. Okay, so that is that. Now next, it is for lead, which is plumbum. I think it's plumbum. Okay, so sama juga dia bagi kita atomic mass lah. Right, let me just do that. This is a lot of questions. So this is PB, this is 206, this is 82. And then given the molar mass of plumbum ataupun lead to be equal to 205.974440 U. 974440. Okay, so sekarang ni kita perlu cari juga the same thing, mass defect. So this is ZMP and MN minus mass of nucleus. So this is really similar to the previous one. I'm just gonna quickly give you the answer lah. You'll have 1.741752 U. Okay, so remember how to do the mass of nucleus lah. I'm just gonna write it here lah. So it's gonna be the molar mass of plumbum or lead minus dengan Z darab dengan mass of electron. Okay, this is how you calculate the mass of nucleus. Lepas tu the binding energy in mega electron volt, it's gonna be delta M 931.5 mega electron volt, and you will get 1622 mega electron volt. And then this is gonna be delta M times with 1.6 times 10 negative 13 joule. So this one will be in mega electron volt lah. Okay, so kamu akan dapat 2.6 times 10 negative 10 joule. Lastly, for the binding energy per nucleon, it's just going to be 1622 divided by A, which is 206, and you will get 7.876 mega electron volt per nucleon. Okay, so